For the third capacity matrix, we have to do something. We have to figure out the speed of our planet around our star, and then we have to figure out how long it's going to take to make the entire trip around our star. So I'm going to use an example of the sun, and my planet is going to be the Earth. You're going to use slightly different numbers, but I just want you to see how we use this equation to go step by step. So first thing I want to do is go to the capacity matrix. And if you look at the capacity matrix, if you look down in the second little section, it says determine a planet's orbital speed. So remember orbital speed. And you're going to do it at the inner and outer boundary of the habitable zone. I'm just going to do it at the radius of the Earth. So if you look over in the what is my evidence section, there's two little links here. The first one is a link. And this link, the astronomy notes link, is going to give us an equation that we need to do in order to figure out this, this speed. And the second one is this, is the gravitational constant. It's this 3.964 times 10 to the negative 14th, which is a really small numbers. And it's AUs cubed divided by the solar mass of the sun divided by seconds squared. So I'm going to copy that for now. And then I'm going to go to the link. When I go to the link, I'm going to scroll down. What I'm looking for, again, is what was in that leftmost column. I'm looking for the orbital speed. So if I scroll down far enough, I'm going to get to this section that says orbital speed. And I'm going to take this equation that shows up there, and I'm going to paste it into my notebook, or you might just copy it into your notebook. So I'm going to go over here into notebook, and I've already pasted it in here. So the speed of my star is equal to the SQRT, which you might have figured out is the square root of the gravitational constant times the mass of the star divided by the radius at which the planet is traveling. So what I'm going to do is I'm going to rewrite this, except instead of the G, the M, and the R, I'm going to put the actual numbers for my star and planet. So the first thing I want to do is to write a big square root symbol. So instead of writing SQRT, I'm going to write a big square root symbol. And then I'm going to paste in my gravitational constant. So here it is. Just need to make it a little bigger. Okay, so I'm going to take that gravitational constant and I'm going to multiply it by the mass of my star. Hopefully you already figured out the mass of your star, possibly in the star in the box animation. Because I am working with the sun, the mass of my star is 1 solar mass. So for this M, I'm going to put a 1, and I'm going to put an M, which stands for solar mass. So underneath that, I'm going to put my R, or the radius at which my star travels. Because the Earth is 1 AU from the sun, I'm going to put 1 AU under there. Yours will be different. Yours, if you recall, is the RI and the RO from your habitable zone. So you're going to use each of those in a separate set of equations to do this. So what I'm going to do is I'm going to put my R, which is going to be 1 AU. Okay, so now we can start to do math. So what I'm going to do is I'm going to start with the information that's in the parentheses, which is the stuff above the division sign. As you know, when you multiply a number by 1, it remains the same. So I'm going to write basically everything the same, including the numbers. So 3.964 times 10 to the negative 14 AUs cubed divided by solar mass times second squared times solar mass. And so what you'll notice is I have solar mass here on the top, or here divided, and then multiplied again. So because it's on the bottom, underneath this line, and above, out here, which is not below that line, I can get rid of both of those m's. So I cross those two off. So, and now underneath the division sign, I'm going to put 1 AU again. So, again, I'm going to write the same answer again, equals, and still the square root. So this time I'm dividing by 1. As you know, just like multiplying, if you multiply or divide by 1, it ends up being the same number. So what I do have on the bottom that I don't have on that isn't necessarily the same as what's on the top is this AU. So notice that there's the AU here and AU cubed up here. So because AU is on the bottom, because it's represented on the top, I can get rid of it to a certain extent in both places. But because there's 3 AUs on the top, I can only get rid of one of them. So I'm just going to reduce that to 2. So when I come down to the bottom, what I end up with is 3.964 times 10 to the negative 14 AU squared divided by second squared. Okay. So now all of that I'm going to square root. So what I'm going to do, I'm going to take out my calculator. Just wait for that to load. And I'm going to take that number, 3.964, and then if I hit EE to the 14th, but remember that's a negative 14, and I hit equals, what you see is what that number should be. So it's this 3.96 with 14 zeros to the left of it. So what I'm going to do is square root that. So I hit the square root sign, and it gives me this long number. So if I count those spaces to the left of this 9 here, it's going to be 1, 2, 3, 4, 5, 6, 7, 8 points till I get to that period. So it's going to be 1.991 times 10 to the 8th. Times 10 to the negative 8. And again, so now, because I've square rooted it, I take the square root of AU and the square root of seconds as well. So what I'm left with is AUs per second. So this travels 1.991 times 10 to the negative 8th AUs, which is the distance of the sun and the earth, per second.